Hello everyone, so today I am going to explain about how to find edit distance for approximate string matching. Approximate string matching is widely used in computer science for DNA sequencing or natural language processing, where the task is to find an approximate match of a pattern in a given text. Now to calculate the approximate match of a given text to a given sequence, we need to calculate the edit distance between the two. Let's take a look at this example. Let's say this is sequence A and this is sequence B. Now we need to find the difference between these two sequences. That means how approximately they match. Now in order to quantify this approximate match, we will find the edit distance between these two sequences. So to calculate the edit distance, we will calculate the minimum number of operations required to transform sequence B to sequence A so that they both perfectly match. Right now they both are not matching perfectly, but our goal is to count how many operations we need to make this equal to this. When we see operations, we mostly include single character operations. The types of single character operations that we will count over here is substitution, to substitute one character to another, insertion, to insert one character, and deletion, to delete one character. Now let's try to count all these three operations for this example. So now we will align A and B sequence together. Now first, in the first location we will see K does not match with S. That means we need to substitute K to become S. So this requires one substitution operation. This I and I perfectly match, so we don't need any operation. T and T perfectly match. Here also we don't need anything. Same goes for this particular character as well, these two characters. Now coming to this, E and I, they both don't match. That means E needs to be substituted to I so that they both match. So here also we need one substitution operation. N and N perfectly match, so we don't need to calculate or we don't need to do anything over here. Here there's nothing, but we have a G over here. That means in order to make sequence B to be equal to A, we need to insert a character G. That involves one insertion operation. So now what we found is we have to do three different operations to make B same as A. That means the edit distance over here between sequence A and sequence B is 3. Now this is not feasible to do it for longer sequences. So for that, we have to incorporate dynamic programming. Now let's try to understand how we will calculate edit distance using dynamic programming. To find edit distance using dynamic programming, we will first make a dynamic programming matrix like this and align both the given sequences A and B across the rows and columns. Now to find the edit distance, we will fill each and every cell of this matrix, and whatever the answer, whatever the value we will get over here, this will be our final answer. Now how will we fill up all these things? Dynamic programming involves breaking down a larger problem into smaller subproblems and solves it incrementally. Here also, each and every cell constitutes one subproblem, and then we will solve each and every subproblem by filling up each and every cell of this matrix entirely to get our final answer. Now let's understand how will we fill the cells. So we will not fill the cell first entirely. First we will only fill the first row and the first column, which we call it as initialization step of the dynamic programming. Now let's initialize the matrix first. So here what we will see, the first row and the first column, this cell, this is null, there's nothing to be done, so this is 0. Also I'll explain that this cell, which is our one subproblem, this calculates the edit distance between sequence B till third column to sequence A till 5th row, and that's why this particular cell gives us the edit distance of sequence A till 8th row and sequence B till 7th column. That means the entire sequence A and sequence B. That means our final answer. So now let's fill it up. Here S. So if we just see over here, from here to here, one S needs to be substituted. Sorry, one S needs to be inserted. So one insertion operation, that means one edit distance. Similarly, this will be 2, this will be 3, that means 3 insertion, 4, 5, 6, 7. Similarly, now let's fill up the first row over here. Now let's look at only this. And here what we need to do is we need to delete K in order to become a null character. 1 deletion, 2 deletions, then 3, then 4, and 5 and 6. So now we have initialized our matrix. Let's start filling up each of the rows. So we will go in this direction. So first we will fill up this particular row, then we will fill up this particular row one by one to fill the entire matrix. So to fill up each cell, we will take a look at its corresponding row and the corresponding column. So the corresponding column is second column and second row. This is S and this is K. They don't match. Because they don't match, what we will do is we will find the minimum value from its neighboring cell. So its neighboring cell that we will consider is up, left and diagonal. Now what is minimum over here? The minimum value is 0 out of these 3. So whatever is the minimum value from its neighboring cell, we will add 1 to it. So this becomes 0 plus 1, 1. And now let's try to see a match condition, because this also does not match S and I. So here also we will do the same thing. We will take the minimum value of 2, 1 and 1. 1 is minimum, that means we will add 1 to it and this becomes 2. Now let's try to find out this one. Similarly, we will fill this entire thing. Now let's try to find out this one. Here K and I, third row, second column, K and I does not match. That means we will here also find out the minimum value of 2, 1 and 1. This will be 2 because 1 is minimum plus 1 is 2. Now here we get a match condition. If we see third row character I, third column character I and I match. So in the match, what we will do is we will simply copy the diagonal value, that is 1. We don't need to do anything over here. We will just copy the previous diagonal value over here. And that's how we need to fill up the entire matrix. So now I filled up the entire matrix. So as I mentioned, the bottom rightmost cell will give us our final answer. The value is 3, that means 3 is the edit distance between sequence A and sequence B, and we already found it out in the initial section of the video. So that's how we will calculate the edit distance of any given sequence A and B using dynamic programming. Thanks for watching.